Welcome back to another episode of Derivative Examples. This is the third episode, and this is basically a series where I go through examples because I know the best way that I used to learn how to do derivatives was when I used to watch people do them, and then I would pick up techniques, or I'd just watch it, and you pick up things from watching it. But so yeah, I just go through these examples. If you know how to do them, you can stick around and watch them if you want, but if you don't know how to do them and you want to learn how to do them, that's what these videos are for, and that's what I'm going to do. So these are the three examples, and I'll do them in this order, and I'll get to it. So here I have example 1, y equals bracket 1 plus x to the power of negative 1, bracket, and all of that's squared. So I'll be using the chain rule here, no notation, just the techniques of the chain rule. Derivative. With the chain rule, you derive the outside function while keeping the inside function the same, and then you multiply it by the inside function. That's what we're going to do. So the derivative of the outside, bring the 2 down, and then keep the inside the same, and then take 1 off the power, to be to the power of 1, because 2 take 1 is 1, and then we multiply it by the inside, the derivative of the inside. Derivative of 1 is nothing, plus the derivative of x to the power of negative 1. We bring the negative 1 down, and we take 1 off the power. So if we take 1 off negative 1, we end up with negative 2. For those who don't know, I'll write it up here. X to the power of negative 1 equals 1 over x. So I will use this when simplifying it later. So I'll multiply the negative 1 onto the 2. And then I'll multiply the x to the power of negative 2. And then just fill this in. I won't write to the power of 1 because if it's there, it's already to the power of 1, so I don't need to write that. Okay, now I'm going to finish this in one step, which is only really one step anyway. I'm going to use this technique. If it's to the power of negative 1 and it becomes 1 over x, then if it was x to the power of negative 2, then it'll be 1 over x squared, which is what I'm going to do here. Negative 2 over x squared. The negative 2 stays on top, but it's multiplied to x to the power of negative 2. So I bring the negative 2 on the bottom, the x to the power of negative 2 on the bottom, which turns it into an x to the power of 2. And I multiply it to the brackets, just keep it the same, 1 plus 1 over x, because x to the power of negative 1 is 1 over x, x to the power of negative 1 is 1 over x. And that's it. That's pretty simplified. So, well, as simplified as you should need it. So I'm going to leave it there and do the next example. Example 2. Y equals square root of 5x plus 7, the square root of 7, over x. Okay. I'm going to rewrite this and then explain it. Okay, so this is the exact same as that up top. What I've done is, because 5x is square rooted, the square root, when you have a square root, you're just putting it to the power of a half. You can just, because those two there are the exact same. To the power of a half is to square root. And over here, I've got a square root of 7 multiplied by x to the power of negative 1. Just like before, I have something over x, so I have something multiplied by x to the power of negative 1. Okay, I've brought it up. And the reason I've put put this to the power of a half and not this is because I'm going to derive this because this has an x in it, whereas this doesn't have an x in it. It's just a constant, so I'm going to leave it that way because I don't derive this. Anyway, we'll derive this side, 5x to the power of a half. Bring the half down, 1 over 2. Leave the inside the same. Take 1 off the power. A half take 1 is a negative a half. Multiply by the derivative of the inside. Derivative of 5x is just 5. Now we add this, the derivative of this side. Derivative of, because there's an x here, because it's multiplied to an x, we just leave the square root of 7 there. Multiplied by, we'll bring the half down, negative a half. Negative 1, we'll bring that negative 1 down. And we'll multiply it back to the x and take 1 off the power. Negative 1 take 1 is negative 2. Okay, so I'm going to rearrange and simplify here. Bring the 5, multiply it onto the, I'm going to multiply the half onto the 5x to the power of negative a half, and I'm going to multiply the 5 on. So it's going to look something like this. Because what I've done is I've multiplied the half to it, which brings it 2 on the bottom, and then I've multiplied the 5 on top of that, which brings it on the top. Plus square root of 7, that stays there, except now, because there's a negative 1, it's a minus. And that is multiplied to x to the power of negative 2. Okay. Final step. I'm going to have 5 over 2 square root of 5x. Now what did I do here? Because it's to the negative power, I brought it onto the bottom. Step 1. And because when it comes on the bottom, it becomes a positive power, it's now 5x, and then it's all going to be to the power of a half. Just like up here, where it's to the power of a half, and that's the exact same having its square root, instead of writing 2 multiplied by 5x to the power of a half, I just wrote the square root there to make it look neater. And then we put the minus sign in, and square root of 7. And then I'm going to bring that to the bottom and make it a positive power. And therefore it'll be x to the power of 2. Or square root of 7 over x to the power of 2. And that there is the derivative of that function at the top. Now I'm going to do a third example. This one isn't necessarily difficult, but I know there's some people just get confused sometimes on this. Okay, so we got y equals 4 over 3 pi x to the power of 3. Now this is actually the volume of a sphere, and I'm going to derive it, and I should get the area. So when we derive it, we have the 4 over 3, multiplying it by pi, and then we multiply it by the derivative of x to the power of 3. So we bring the 3 down, multiply it to x, and take 1 off the power, so it's 2. Now I know some people actually think, because they see numbers, and then they see pi, which is the symbol for a long ass number, but they see pi and sometimes they get confused and they try and derive it and get rid of it, or they'll do the product rule to solve this because they'll think for some reason that this is a variable when it's not, it's a number. So you just leave it there and treat it as if it was like a 7 or if it was a 13 or just a number. Once the x's go, and if it's on its own and you derive it, then it becomes 0. But if there's an x multiplied to it, you derive the x and leave this alone. So simplified, we have divide 3 and we have a multiply by 3. So we cancel these out. And what we end up with is 4 multiplied by pi multiplied by x squared. And that is the area for a sphere, which is what happens when you derive the volume, you get the area. And that is this lesson done. I hope it helped. Thanks for watching. Leave any tips if you think I should do any better on something, but in that case, thanks for watching. Have a good day.